Welcome to our discussion about the normal distribution. In this video, I'm going to describe some of the standard features about the normal distribution or the normal probability distribution. And then I will be sharing how those features can be turned into different types of test questions. So let's start off by thinking about the normal distribution. What the normal distribution means is that it is a bell-shaped curve that we often see kind of in the natural environment. Not everything there is normally distributed, but it is a symmetrical bell-shaped curve like the one that you see here. And this particular curve has some features. Specifically, the very middle of it is where the mean lies, the geometric mean, and that is the line that the curve is symmetrical around. So the left and right hand sides of the curve are symmetrical, or at least they should be. Mine might not be totally perfect, but this is the middle. And one of the things that you've learned is that the mean, if it's symmetrical, is also where the median will be. And so the mean and the median are both right there in the middle. The other thing about this curve is that approximately this far away, you have plus and minus 1 standard deviation away from the mean, so minus 1 standard deviation. And approximately here, you have plus and minus 2 standard deviations. And if we were to go far enough, then we would have plus and minus 3 standard deviations, about yay far away. And so this demarcation, no matter what scale this normal distribution is on, approximately plus or minus 3 standard deviations encompasses the entire normal distribution. Now, there are several ways that we can label across this scale, and one of them is something called z-scores. And so I'm going to put all the z-scores here in green. And the thing that you'll need to know about the z-scores is that the mean of the z is 0. So wherever that middle point is, that symmetrical line around the middle is 0. And the standard deviation of the z-scores is 1. And so this is plus 2, plus 3, minus 1, minus 2, minus 3. So a z-score of minus 1 is right here in this location, or a z-score of plus 2 is in this location. And these locations also demarcate the percentage of the population that falls within a certain area. So this red curve is a curve that we have all the area underneath the curve. The total area is equal to 1, or 100%. And in these specific areas, then we'll have just a percentage of that total area. So in this first section right in here, everything that's between plus and minus 1 standard deviation is 68%. So that would be everything that's shaded right in that area. I'm going to get rid of that shading just because it's in the way. But so that's 68% of the total area under the curve, or 0.68. The next area that we should be sure that everybody knows about is plus or minus 2 standard deviations, and that is 95% of the total area. And I can shade that in right here. So that whole area from here to here is 95%. So let's go ahead and get rid of that just because it's kind of messy. What that means is if 95% is from this area right here to this area right here, that leaves 5% in the remaining tails that are out, go all the way out to here. And so if there's 95% in the middle, then each of these tails is equal to 2.5%. These are probably the major things that people should remember about the normal curve. The last thing, and I'll put this in black, and this is plus or minus 3 standard deviations, so all the way out to here, the area that is included in that portion of the curve is 99.7%. So there's only 0.3% that is really beyond this, and 0.15 in each area, obviously. So a very small percentage that's beyond 3 standard deviations from the mean. Those percentages are going to be the basis for everything that you do in terms of questions related to this graph, this normal distribution. And so the kinds of questions that you'll get all relate to these percentage breakdowns. So if we have 2.5% that's out here in the curve and 95% in this kind of plus or minus 2 standard deviations right in here, then what that means is, and then the 68% here, what that means is that if we just shaded in this left side right here, that's half of 68%. And I'm going to put all of these numbers in orange so that you can see how they add up. So this is 34% right here. And this side over here is another 34%. This area in just this part right here is 13.5%. And right here is another 13.5%. If you add up these 4 percentages, 13.5, 34, 34, and 13.5, that's where you get this total of 95%. So what we know is that greater than 2 standard deviations is 2.5%, less than 2 standard deviations is 2.5%, between minus 2 and plus 2 standard deviations is 95%, and between 1 and negative 1 standard deviations is the 68%. So there are just a variety of different ways that we can add things up in this particular graph. So that is how we deal with the z-scores. One thing that I'd like to point out is that the mean and the median z-scores are equal to 1, and the standard deviation, or sorry, mean and median are equal to 0, and standard deviation is equal to 1 of this z-scale, the z-scores. So let's do an example. And the example is of IQ scores. The mean in just sort of a general population, the mean IQ score is equal to 100. And so if you were asked what is the z-score of a population that has a mean equal to 100, well, you can see here that the z-score is equal to 0. So if it's at the same thing as the mean, then that would tell you that the z-score would be equal to 0 because it's in the middle. Also, we know that the standard deviation, I'll write that here, is equal to 15. So what we need to do is we need to take 100 and add 15 to it in order to get the value that goes right here. So what is 100 plus 15? If you came up with 115, you were absolutely correct. Let me get rid of this little box. And if you were to then go, so that's 1 standard deviation away. If you were to go 2 standard deviations away, it's another 15. So this would be 130. And if you were to go another standard deviation away, all the way over to 3, then you would have 145. So here we have 100, 115, 130, 145. And so those are the values that correspond to plus 1 standard deviation, plus 2 standard deviations, and plus 3 standard deviations for this example where the mean is equal to 100 and the standard deviation is equal to 15. We could similarly go down by 1, 2, and 3 standard deviations by subtracting 15 each time. So the 100 minus 15 is 85, 85 minus 15 is 70, and 70 minus 15 is 55. So these really demarcate the minus 3 standard deviations, the minus 2 standard deviations, and minus 1 standard deviations. And mapping this out in this way really comes in handy in the future. Now I'm going to add one thing before I go on, and that is actually a little bit of truth in advertising. This 95% confidence interval that ends here and here, in reality, this is minus 1.96 standard deviation, plus and minus. But for the purpose of example, we're just going to use the minus 2 and the plus 2. So if you end up with a question and they're off by just a tiny little bit, the difference between 1.96 and 2 is a small but real percentage, then you would just need to go with the answer that is that little bit of difference. So that would help you maybe realize that instead of being 70, it would be 70 point something, and I'm not sure what that point something would be. All right, so there is an example. Another kind of question that you would need to answer is, let's say there's a researcher that took a sample of 1,000 people. How many of those 1,000 people would you expect to be in each of these ranges? And since I chose 1,000, it's actually going to be quite easy to do the calculation. Sometimes they would ask you to do something where it's not quite so straightforward. They might give you a sample of 400 and it would be a little trickier. But we know that between 85 and 100, there's 34% of this whole population. So here we would have 340 people. Also, up here on this top part, there would be another 340 people. So this total number of people between plus and minus, between 85 and 115 would be 680. So, and that definitely corresponds with the 68% that we see here. Similarly, we could map out the number of people that fall between 70 and 130. That whole range should have approximately 950 of the 1,000 people, or the 95%. And we could do something where we say, okay, well, how many people would we expect to be between 55 and 145? And the answer is 997. So there would be only 3 people out of this sample of 1,000 people, like all the way from here to here. There would be only 3 people that would be either above or below that range. So this is 997 out of 1,000. The other question that is very commonly asked, and it's just because we really like this this area right here, plus and minus 2 standard deviations. A lot of times we want to know what percent is above the 130. So if you took 1,000 people, how many would you expect to be above 130? And the answer to that is 25. So you take 2.5% of 1,000 and you end up with 25 people. Or you might have the question asked, how many people would you expect to be below 70? And the answer again would be 25. So that those converting numbers, converting the the scale that we have here in the example to the actual numbers based on a given sample size can often be a typical question. So let me show you what some of these typical questions are and how they relate back to the graph that we were just looking at. So one of the questions that you may get in a standard kind of like a multiple choice type test like the CPH exam would be, what is the mean of the standard normal distribution? And if you look at the mean here, the mean of the standard normal distribution is 0. What is the median? Now what we know about a standard normal distribution is that it is symmetrical, and so the mean and the median should actually be the same. So should not also the median be 0? And the answer to that is yes. What is the standard deviation of the standard normal distribution? And by definition, this whole concept of standard for the standard normal is that the standard deviation is equal to 1. So those are really straightforward questions because they're really testing just your kind of baseline fundamental knowledge. The trickier questions are when these are starting to be applied to a particular scenario. And so here are the usual scenarios. A lot of times they'll say the variable age is normally distributed. And then they launch into one of 6 different questions, and there really are only 6 flavors of this particular question. So let's number these. So here we have 6 different ways of asking exactly the same question. They're really just, all of them are getting at this information that we looked at on the graph. What percent of the sample is expected to have a z-score, and then they would fill in with higher than, lower than, or between a particular z-score number. So let's actually do a couple of those. What percent of the sample would you expect to have a z-score greater than 2? And the answer is 2.5. What percent of the sample would you expect to have a z-score less than 2? And that would be everybody else, except for the 2.5 that we just pointed out. So 97.5% would be everybody below a z-score of 2. So you can kind of see where this is going. Or what percent of the population, or sorry, what percent of the sample is expected to have a z-score between -2, let me get a red pen here, -2 and +2? And the answer to that question is 95%. So you could ask between -1 and +2, what percent would be there? And so then you would have to start adding up these little individual percentages, 68% plus 13.5, and that would get your answer of -1 to +2. Or what percent of the population would you expect to be less than a z-score of 1, or sorry, less than a z-score of 0? And the answer to that is half, or 50%. So those are some of the kinds of ways that they can be asked. If an individual has a z-score of something, then this person is higher than or lower than what percent of the sample. So let's say an individual has a z-score of 2. This person is higher than 97.5% of the population because only 2.5% is higher than 2. If an individual has a z-score of -1, then this person is lower than what percent of the sample? So you can see how there are just a number of different ways that you can manipulate that question. Both of these have to do with z-scores. And so we're really looking at the kind of pure values. These next two, you have to take the value that you're looking at and convert it to a z-score, and then you can answer the question. So those are really a 2-step question. So you would start by saying a variable age is normally distributed with a mean of blah, 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 and a standard deviation of something else. So then here we are, we're in example mode. And so in our minds, we have to map out where all these numbers fall so that we can know what where the breakpoints are. And so let's say what percent of the sample is expected to have a value higher than 115 if we have this particular scenario. And so that would be 13.5 plus 2.5. So 13, 14, 15, 16%. So 16% of the sample would be above an IQ score of 115. If an individual has a value of such and such, then this person is either higher than or lower than what percent of the sample. So these two questions are really getting at the same thing. They're just asking it in a slightly different way. So that's two more ways that you can ask the question. And then the third way adds a whole nother layer of complexity. So researcher draws a sample of 1,000. Okay, start at the beginning. A variable is normally distributed. It has a mean of standard deviation of such and such, and then the researcher draws a sample of this many people. So this can be asked then in either of these different ways, either the z-score way or the value way. What is the expected number of people who have a z-score that is higher than 145, that is lower than 85, that is between 70 and 130? So you can ask that question in so many different ways, but really you are just taking the percentage that you would get and multiplying it times that sample size. So if they don't give you a sample size of 1,000, if they give you 400 instead, then you would just need to figure out how am I going to calculate the sample size of that particular population. And usually they try to give you pretty round numbers, and you can get that with some very basic math. The corollary then is what percent of the population has not the z-score, but the actual value itself. So those are really just the only 6 ways that you can ask those kinds of questions. As long as in your mind you can manipulate this particular normal distribution curve and move from sample to the actual mean of standard deviation, back to z-scores and back down again, you should be able to answer any of those questions fairly easily. In a testing scenario, they'll give you the kind of math that you can really do very simply, that you're not having to do something super complicated. So again, you may end up with these situations where they give you something that is 1.96 times that, and so the number might be 129 instead of 130, but that's really going to be the only numbers that are even in the ballpark. If they gave you 115, 129, and 145, you would know that you would have to pick something that was much closer to 130. So mental math will be your best friend in this particular scenario. So that is my overview of the normal distribution. I hope that's been helpful.